Okay, the last section we'll do today is section 4.4, which is called the Fundamental Counting Rule. What this pretty much says, in real life, if you went to Subway and you ordered a sandwich, like when you get in line, you have like 5 choices of bread. You may have 10 choices of meat. You might have, 20 choices of veggies, 2 kinds of sauce. All you'll do to figure out the number of possible sandwiches that you could order, like the different combinations, like you might order turkey with provolone and you put peppers on it, or you might do ham and then American cheese, and then you do, I'm just thinking, like spinach and then a sauce. If you just take those different possibilities and multiply them together, you will have the total number of combinations, which is what that first slide says. Okay? If repetitions are permitted, then the numbers stay the same going from left to right. We're going to talk about this. If repetitions are not permitted, then the numbers decrease by 1. All right, factorial is a big thing that we'll be talking about. For some reason, I don't have my calculator with me, but hold on a second. Okay, here's my calculator. I was going to show you real quick. Factorial means that you take a number and you decrease it and multiply. So 5 factorial, that's what the exclamation point means you multiply 5 times 4 times 3 times 2 times 1. There's a key on your calculator on this black one. If I found 5 factorial, I know you can't see very well, but on these you could hit it, 5 factorial one time, hit enter, it gives you the answer. So there's a factorial key in pretty much any scientific calculator. Alright, a permutation is an arrangement of objects in a specific order. Specific order is important, okay? Here is a fancy rule. NPR is on a scientific calculator. You need to have one to do these problems. You do not have to use this formula if your calculator will do it for you, okay? N, though, represents the number of objects, and R is how many that's taken at a time. Okay, there is another rule. I gotta go back, hold on, because we need to handwrite this one. Let's see, it's in our book. It is on page 231. So the permutation rule says this. This is if there's repetitions that are happening. So that's n factorial over r sub 1 factorial, r sub 2 factorial, dot, 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 r sub n factorial. And this is on page 231. If you need to go back and look at it and look at the examples that go with it. All right, moving on. A selection of distinct objects without regard to order is called a combination. If order is important, it's a permutation but not a combination. Here's the formula for combinations. N is the number of objects. R is how many is taken. The calculator, you're going to see this. You can just punch it in. You do not have to plug in the formula. And let's go do a little practice. Okay, I need you to take your book. Let's turn to page 235. Page 235. And we'll do a few problems right here. Okay, let's start out with number 1. how many 5-digit zip codes are possible if digits can be repeated? Okay, I got 5 digits. I've got 10 possibilities for the first number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 possibilities. 10 for the second, 10 for the third, 10 for the fourth, 10 for the fifth. I multiply all those together. So there's 100,000 possibilities. Okay, the second part of this says if there cannot be repetitions. Okay, we still got 5 digits. Still 10 choices for the first blank, but then things can't be repeated. So then there's 9 choices, 8 choices, 7 choices, 6 choices. Multiply that's 30,240. Alright, that's called the fundamental counting principle. Alright, let's go to 3. 3 says, how many different ways can 6 identical video game cartridges be arranged on a shelf? Okay, so you got to arrange 6 video games. So I have 6 video games to place first. One's already there, so then I have 5, then 4, then 3, then 2, then 1. Multiply those, which is the same thing as this. Final answer is 720. Okay, next we're jumping to 9. 9 says a knitted hat pattern comes in 4 styles with 4 stitch options and 3 sizes, and there are 7 yarns appropriate for the hat. Disregarding size, so we're going to toss out the 3 sizes. Okay, how many different hats can be made? So I got 4 styles. I've got 4 stitch options, disregarding the 3 sizes, and 7 yards. So I just multiply those together. Answer is 112. Okay, let's look at 11. 11 says, given the characters ABC, HLT, UV, 1, 2, 3, and 4, how many 7-character passwords can be made? No repeats are allowed. Alright, let's talk about this one. We'll save that second sentence for just a second. This problem might be easier to use what's called a permutation, which P means the position is important. Okay, there's 12 characters that you need to have could have in your password, but you're only choosing 7 of those. I go to my calculator. All scientific calculators, you can punch that in. You just got to figure it out. If you can't, let me know. Plug in the formula if you want to, but you don't have to. The final answer is 3,991,680. Alright, the second part of 11, how many, if you have to use all 4 numbers, video, you're fine. If the first 4 characters in the password, this is for Taisha.
I heard you yesterday talking.
Yes, that was crazy. Alright, Taisha, that was your mama. Okay. So we've got 4 choices, times 3, times 2, times 1, and then we got 8 times 7 times 6. So the final answer is 8,064. All right, we're moving to 15. Uh, 15 says, how many different 4-color code stripes can be made on a sports car if each code consists of the colors green, red, blue, and white? All colors are used only once. Alright, this is what I would do. 4 times 3 times 2 times 1 there are 23 or 22 threatened species of reptiles. In how many ways can you choose 4 to write about? Order is not important, so this is a combination. There's 22 combinations, choose 4. Answer is 7,315. Okay, 19. 19 says, how many different 4-letter permutations, so this is a P, can be formed from the letters in the word decagon? Well, there's 7 letters in the word decagon. Choose 4 of those. Punch it in. Answer is 840. All right, let's jump to 23. All right, 23 says, how many different ways can 4 tickets be selected from 50 tickets if each ticket wins a different prize? Okay, since they win different prizes, it's a permutation. So that's 50, choose 4. The answer is 5,527,200. All right, let's jump to 29. This is one of these identical permutation problems. Well, that's the formula that we hand wrote. So 29 says, how many different 9-letter code words can be made using the symbols? And we got some symbols. All right, now if I look at the symbols, there's 9 of them total, so that's n factorial. We want to divide that by the number of each. There's 4 percentage signs, so that's 4 factorial. There's 3 and signs, and there's 2 plus signs. If I punch that in the calculator, it should give me an answer of 1,260. Okay, 31 is another problem like this. 31 says, how many different ways can 6 identical books, 3 identical paperbacks, and 3 identical box books be arranged on a shelf? All right, there's 12 total. When we want to divide that by 6 factorial, 3 factorial, 3 factorial. And that means to multiply down there on the bottom. So that's 18,480. All right, well, let's do a couple more problems. We'll stop. Let's jump to 35. All right, 35 says, in how many ways can a person select 3 coins from a box containing a penny, a nickel, a dime, a quarter, a $50, and a $1 coin? Okay, this is a permutation. There's 6 coins, and I want to choose 3. So that's 120. Okay, 37. How many ways can a committee of 4 people be selected from a group of 10? That is a combination, because it doesn't matter who's on the committee. And the answer is 210. Okay, let's finish up with 51. All right, 51 says, how many ways can a person select 7 television commercials from 11? All right, it doesn't matter the ones you choose, so that's a combination. So 11, choose 7, and the final answer is 330. Okay, that's everything, I believe. Like I say, any kind of questions you have, please let me know.